Hello, good morning to all of you. This particular video is about Encoder Decoder GRU Architecture for English to Hindi machine translation. The core idea behind this video is to help you understand what really is the encoder decoder architecture, why I have used the GRU or LSTM or RNN for machine translation, why not CNN. Then we will move on how the GRU will operate. We will learn some of the key concepts such as what is the hidden size of any RNN cell, what should be the uh, shape of the input which is provided to RNN cell, what should be the output from a RNN cell, how to fetch the hidden states and which hidden state has to be passed to a decoder, and how the implementation is done step by step. I will also help you to understand this full architecture using infographics as well as good presentations and images. Further, we will also discuss about the roadmap, which is most important, that how we are making or computing this. So the roadmap is also discussed here, and that roadmap will contain gathering research, how we are manipulating the data, making the vocabulary, using the regex to clean the data, how the model architecture is developed, how iterations will go, how we can create our own batch sizes, how we can create our customized epochs, and finally I will try to make some prediction from the model with a customized approach. Thank you. Now let us start the work. First of all, let us understand encoder decoder architecture using the concepts of artificial intelligence. Let me say, if I say difference between before that, RN is of two types, that is LSTM and GRU. And before that, let us understand that why to use RNN in machine translation, why not CNN. See, CNN or the convolutional neural network is used for such problems where there is a fixed input and the fixed output is there. Like I need to do the image classification, or I need to do the task like that. There we will use the CNN. But when the input is of variable length and the output is also of the variable length, there we will make the use of recurrent neural networks that has the memory to understand the data, to save the data, and which can be used for the prediction. Like in a simple examples, we all say that we will just say two examples. The first example says that Rahul is a member of Indian National Congress. Second, I say Rahul is a good cricketer. So if you don't understand the full context, you can't tell what is the name entity recognition of Rahul. It needs to understand the context to give a prediction. In that sense, we will use a bidirectional LSTM. So in short, RNN or recurrent neural networks are used in such cases where we need to understand the context to give a prediction, as well as we don't have the fixed input and fixed output type of structure. When I talk about the machine translation, it is also a type of a task which can be handled well with the RNN. So that's why we will go for the RNN. Now, the question is that do we proceed with the LSTM or GRU? Means there should be some difference between them. So to understand the difference, let me share you one of the posts which I have written, and fortunately it is the top ranking in Quora. So difference between RNN and LSTM. I say GRU, sorry, LSTM and GRU. Let me see in the Quora. Does this comes in the Quora or not? Let me see. Is the difference between maybe I'm not understanding that where I have written it. Let me see. Like just I type my name, then see the result which is coming. Okay, just give me a minute. Sometimes we get a difference output. Okay, so let me see it from here. Okay, so this is the difference between LSTM and GRU, and let's try to open. They say that you need a sign. Let me try to open in the new window. Maybe you will get the results. If not, then I will open it with the but don't worry, I get the result. So this is the difference between LSTM and GRU. So I have written a post and put a code there in the query. You can analyze the code, you can see the results, and also I have also given some glimpse of a bidirectional RN and try to explain it with a diagram, and many people read from that. I get some good votes also there, and it is one of the top ranking answer in the cure also. Thanks for all the readers. So it clearly mentions that the answer clearly mentions that if you're using LSTM, you have three outputs. One is output, cell state, and hidden state. While if you're using the GRU, you have two outputs. One is that the hidden state, and another is output. When you are going for some long type of context, long type of information, you prefer LSTM over the GRU. So they have the different applications, different states, and one must understand that where to use LSTM or GRU. So this machine translation I have implemented using the GRU. So that means one thing is sure, that I will get a hidden state and the output state. So does this make sense? Yes. Now let's proceed. Even I am on the video, but let's proceed step by step. So first step is goal is to create a encoder decoder GRU model for English to Hindi translation. Now if I talk about the GRU model, I have shown a post on the Quora where I have mentioned some of the key concepts behind RNN and LSTM and GRU, and also explained that where to use the LSTM and GRU. When you want to deal with some long sequences, you go with the LSTM. When the sequences are not so long, you can preferably go with the GRU. Okay, so this is just a understanding from my side. There may be a flexibility of a lot and lot of improvement. Now let's proceed further. Okay, so this is GRU. Now the key thing is to understand this architecture. So the whole code has been implemented in PyTorch. First of all, when I am talking about English to Hindi translation, the idea that come to my mind is that I must have the vocab of English and Hindi. When I talk about the vocab of English, I know there are 26 alphabets are there in the English. If including pat, it becomes 27. But what about Hindi? How do I get the characters from where? So to solve this problem, first the development was with the SKY code. But SKY code was limited to some kind of characters only, some type of representations, like representations up to, I think so, 128 characters can be implemented using a SKY code, because it is a 7-bit code, 2 raised to power 7 or 8, maybe something. But to represent about all the scripts and languages, a standard was developed which was called Unicode, and we get the representation of the Hindi characters from the Unicode representation, and so from there I will get the representation of Hindi character. And to my understanding, I think there are 128 characters which are present in the Hindi alphabets, we say, the dictionary that has been created. Okay, so this is some of the key findings that I went, that is called as in the roadmap also I have mentioned it, it is called as the gathering research. This is the important part of any kind of model building, that how much time you spend in gathering the research. First of all, I spent some days in understanding that how to represent the other languages, like I want to represent Chinese, Hindi, or maybe it could be Russian, it could be English, it could be any. So then I read a lot of things and came to a conclusion that okay, I should go with a Unicode representation. That was a standard development. Then there was a key finding about what is what is something which is very important is hyperparameter tuning. Like if I'm using a RNN GRU cell, then I should understand what is the hidden size, what is the meaning of the hidden size. Hidden size means the number of neurons in RNN cell. So we provides a input that a character at some time step, at a particular time step, it is passed through that hidden size. Then we get two things, as one is output, its representation, and then another is the hidden state representation. Then the second question come to my mind when I develop an encoder with the multiple RNN cells, which encoder, which hidden state has to be passed. The answer came from a lot of research, from medium articles, from research articles, that the last state, hidden state of encoder is passed as the first hidden state of a decoder. That's what I represent in the diagram. So the last hidden state of the encoder becomes the first hidden state of a decoder cell. Again, when I then I try to analyze it, what should be the input to a decoder input. Definitely I want to convert this English into the Hindi translation. So definitely the Hindi vocabulary, or the Hindi vocabulary is the input to a decoder. Means if you have a word, you have a length of that word, and we have to represent it in a one hot encoding form with respect to the vocabulary of the Hindi dictionary. That's what. Then come to the conclusion that what is the size of the output, and that output is the new input to the next RNN cell during the prediction. That is, if we are using the ground truth representation instead of the output from the previous cell, then it is called as the teacher forcing. But if I want to get input as the last output of a RNN cell, decoder cell, then means I need to do some manipulation to convert that output into the form in which the input is there. That is a one hot code representation during the input. So these things comes to my mind, that these are the some of the things, some of the key finding I did before creating this, before implementing the code. So again, let me go back to the roadmap. The roadmap was that is to create encoder decoder GRU model for English to Hindi translation. First thing I did was to gather the research, and I read a lot of literature review papers. I read a lot of understandings, what is GRU, what is a neural network, then what is the hidden size of a neural net of a RNN cell, what should be the shape of the input to RNN cell, then what is the coming output hidden state shape and output from the RNN cell, then which hidden state has to be passed to the decoder, and do we need the outputs of the encoder or not. Then during the prediction, what things that we need to store, that is surely the output from each of the decoder RNN cell. So that was all the research and the gathering that has been done. Then I do explain and implement the next part is to clean the data using the regular expressions. There I use the concept of re.compile, which of the things I need to keep in the data, which things I need to avoid from the data, and there are so of the things that came from this data cleaning, and then creating a vocabulary from for English and Hindi using the Unicode representation. Then after that, we know a good understanding of the GRU, how the GRU cells are made it, and then I have created the model architecture. One key understanding from the model architecture is that for each character, the input representation of a encoder is 1, 1, 27, because there are 26 alphabets in English, plus 1 is for the pad character. And if I pass it through a RNN encoder GRU, which has the hidden size of the neurons 256, definitely the output is 1, 1, 256, and also the hidden state is 1, 1, 256. The last hidden state is passed through a decoder RNN, and I guess the Hindi characters are 128. So this is the numbers I have written it, including the pad. Total vocabulary of Hindi becomes 129. So the input to the first decoder cell is 1, 1, 129, and again the output is 1, 1, 256, because the hidden size of the RNN encoder and decoder is same. Then I need some kind of linear multiplication to convert that output to 1, 1, 129, because this is what is the input to the next decoder cell. So there is a linear multiplication is done, linear calculation is done, so that we can get the desired shape for each of the input. Then to convert that into one hot encoding in the PyTorch, we need something like scatter, and then we don't need any kind of back propagation from the output. We need only the back propagation to updates the weight, that is to update the hidden states. So we are de-attaching the output back propagation from the output. That are some of the key understandings of the particular library that we are using. Okay, so this is what helps to write the code. So these are some of the understanding. Then there is a lot of some of the things I have tried to understand and then written in the form of the QRA's answer, and it was fortunate that many people liked about that, commented on that, and tried to give some of the upvotes to them. That's also a kind gesture from them. Then now, what happens then? So again, after we need to focus about two things, that whenever we are creating a model, we need to understand two things: how to create a code for the batch size, then we and then what is the epoch. Epoch means when all the data, all the samples is being seen by the model. So it can it is very vital that during a epoch we can have the different batches are there, and each batch includes a batch size. So if you have 100 samples and you create a batch size of 10, means then definitely you have 10 number of batches, and the number of batches are equal to the number of iterations in epoch. So in short, I can say that the number of iterations are a part of epoch, and the number of iterations are equal to the number of batches are there, and each batch we have a definite number of samples that are so called as the batch number. So these are also some of the key understandings while implementation of the code has been achieved here. Okay, now I'm ready. So let me revise the concepts. So to create a model, I have the vocab, I have the regular expression, I have a vision about creating the encoder decoder architecture created, and then for the architecture it is vital to understand the what is the core of a GRU cell, the number of neurons, hidden state and output state, then created the hidden and output to the shape it wants, then manipulated the shape of the output of the decoder to the shape that it's needed in the input form. And what I need is that I need the output from each of the decoder RNN cell, and that has to be passed to a softmax layer because it is used for the classification. Then a argmax is used to find that index which has the maximum value, and that is a predicted word. Then I have implemented this on the CUDA enabled device because I am implementing the code on GTX 1080 Ti, which is the GPU I have. So GPU is enabled here, and you can see from here also, if you type NVIDIA SMI, you will come to know that this is the version of the NVIDIA, that is the drivers, and this is the GPU which I am talking about, and these are some of the PIDs, that some of the operations or some of the applications which are running on the default. Okay, everything is set. Now let's go for the prediction phase. Again, before going back, let me revise the things. The roadmap is, first of all, the data has been gathered Okay, sorry. Then we have the research was there, data cleaning there, model architecture was developed, hyperparameters were tuned. Then what happens? So I used to pass the batches and the batch size in the data. So it is definite. It is not a batch gradient. It is a mini, not mini batch. Sorry. Yes, it is a mini batch gradient because I have used a batch of 64. If I use a batch of 1, it is a mini batch gradient. Okay. Okay, this is also clear that and what happens in the mini batch gradient is that I calculate the loss in each of the iteration, and that loss is summed and passed to a gradient like Adam optimizer is there. Again in the next batch or in the next batch I have calculated the loss, and the resultant loss is the average of loss that was calculated in the first and this one. So this is how we can say that the workflow of a mini batch comes into the play. Okay, so then what happens? The model was prepared. So this was the model, and after the model we have the English alphabets, we have the Hindi alphabets, and let me try to go with the word Adi. So this is the English word. I just load the model using the PyTorch. Then I need to just see the one of the dir of the model, which gives me all the methods available with the model, and then output. First of all, I need to convert the model into the shape that a model needs it. Then created a Hindi output, an empty string of that. Then from that model, I just got the output that a decoder will provide me. Then find that particular index in the whole vocabulary which has the highest value, means this is the definite predicted word. And then if the index is equal to 0, that means the bad character came. It means I need to break out of the loop, and then I have appended each of the character and then try to give the prediction. So when I run the file, this is the and it gives me some kind of from English to Hindi output. So it is not a very tuned model because I have not used the attention modeling. Uh, Maybe in the next video I will try to explain this thing with the attention modeling and try to improve the accuracy. And even now I am getting the loss of 10%, so which is very high, up to 10, and I need to decrease it in the 0 point something. So I will keep on working on that. But the core concept of this video is to explain you a encoder decoder GRU architecture for English to Hindi machine translation. Along with that, try to explain the concept using well-defined infographics and images. Try to show you the roadmap of that, and try to show you one of the posts which is on the Quora. And along with that, if you are more interested in machine learning and deep learning, you can also see some of my good or top ranking post on that, like one of the thing, this is my official website, and like this is freezing TensorFlow model, like that I am explaining you. This is one of my good posts, and I think it is coming yes, here. So it is coming the first page of the Google, that how we can freeze the TensorFlow model, how we can, and the code has been discussed, the graphs, nodes, and how we can convert the models into the model.graph DFE. This help us to optimize the concepts and can leads to further optimization using the TensorRT. So a lot of articles has been written for the TensorFlow, TensorRT, model freezing, PyTorch, saving and loading the model using these OpenCV, how to do the object detection. Like if I type here object detection TensorFlow model, and you will get something here also. So there is a lot of things I have written on that. You can take the help from them. I just try to write these codes where you could use them and try to create your own. Along with that, you can also see me on the Quora, where a lot of answers has been written by me, like it is on the popular concepts of machine learning, along with that C, C++, RNNs, MATLAB, namespaces, convolution neural network, Thino, TensorFlow, and so on. And if you see on my official website, that is ersanpri.wordpress.com, you can also see some of the high trending topics, and also you can see some of the things on the GitHub also, which like I say that some of the things I have explained on the GitHub also. Same thing is written here also, like how you can read the images using the OpenCV, load or save the Keras model. That is continuing from the last epoch. How the model is saved in the Keras, or if it is a PyTorch, in the state dictionaries, and some simple concepts like self variables, Fibonacci series, text sentimental analysis, Tower of Hanoi, which is one of the important puzzle, simple way to load and save the models in PyTorch, and so on. So this is the things that I'm trying for last few years, and getting some good hope that such kind of videos can help the readers. Thanks a lot for your cooperation.